Hi, Andy from Sony here again, and it's almost fall here in the Northeast. We're about 30 miles north of New York City. It's a little bit windy. You may hear some wind noise coming up, but I decided to go ahead with it anyway. What I'm going to tell you about in this video is our latest fourth generation in our UWP-D series. Now, UWP stands for UHF Wireless Package, and the D in UWP-D stands for DSP, or Digital Signal Processing. You may realize that in many wireless systems on the market that are not true digital, there is companding. Companding is a method by where you take your precious audio at the transmitter, and before you turn it into a baby FM radio station, you compress it. And then you make the radio station, you send it through the air, and at the receiver, you tune it in and you expand it again. And if those compression and expansion methods are built up out of circuitry and circuit design, because there are various tolerances that build up those circuits, you never get a perfect mirror image and you can get audible artifacts. Well, our engineers decided to take DSP and use mathematical algorithms to do that companding scheme. And that's what we do in UWP-D. We hold on to a lot of the sharp transients that occur naturally that might get rounded off or mushed out with kind of traditional companding schemes. Now, the other thing that is important in wireless, as I'm sure you are all well aware, is to prevent dropouts. Perhaps it is the most important thing about wireless. And we've realized at Sony many years ago that the absolute best method for doing diversity reception to prevent dropouts is to do a version of diversity called true double tuner diversity. Sometimes you have a single tuner and double antennas. Sometimes you have a single tuner, a single antenna, and the audio cable acts like a second antenna. Well, in our UWP-D family, in this case, we have two independent tuning sections inside of this one little small battery-operated receiver. Each tuner has its own separate antenna, and then there is a comparator circuit whose job it is basically to compare the signal between the A tuner and the B tuner and always offer up the best one. And even if a dropout condition even hints at happening on one of those tuners, the comparator circuit noiselessly switches very quickly to the other one, which, because of the wavelengths involved, almost impossible to have a dropout condition on both tuners and antennas at the same time. So we really try to protect the wireless user with dropout-free condition. Now, another thing that can really save you is, and I'm sure you're all well aware, is spectrum. And we've all been wrestling with the FCC spectrum auction over the last couple of years at least. And these little units have a very wide tuning range of 72 megahertz or 12 UHF TV channels. They can tune in up to 2,772 discrete individual channels and 25 kilohertz increments. And that is kind of important depending on where you are. So we offer these units in three separate block configurations, if you will. One of our units is available, or one of our packages, or all the components are also available in what we refer to as the 14 block. A 14 block really goes from UHF TV channel 14 all the way up through TV channel 25. That's 12 TV channels. Each one is 6 megahertz wide. That's 72 megahertz of bandwidth. We also have a 25 block version of the same equipment, and that goes from TV channel 25 up through 36. Now, additionally, we have our 90 block. And the 90 block is kind of interesting because it's way up in the 941 to 960 spectrum, where a lot of people have started to go. And I've been working with some location sound mixers in the very crowded LA area, LA Basin area, and they are thrilled to have those additional frequencies up in the 941 to 960 range, which are basically kind of much more open and available than down in the traditional UHF frequencies. So that's a nice thing. Now, one of the things you always have to do with wireless mics is find the best and quietest open available channel. And we have historically done that through menu choices. You'd go into the menu on the receiver, you would tell it to scan, and it would scan, and then we'd have little infrared ports, and they would talk to the transmitter, and the transmitter would get its channel information from the receiver. But in the latest 4th generation of UWP-D, we have made that even easier. You don't even need to go into menus anymore. As a matter of fact, what we do is we are taking advantage of NFC pairing, NFC being that little logo that you find on the back of your cell phone that allows you to pair up your cell phone with Bluetooth headphones or a Bluetooth speaker, for example. Well, we use that kind of NFC pairing to communicate between the receiver and the transmitter. And as I said, you don't even have to go into menus to tell this unit to scan anymore. There is a top panel dedicated button that says NFC Sync. You simply hold it down for about 3 seconds. The unit will start scanning in the band it's in or in the block that it's in, and it will then find the quietest available channel. It will flash the OLED screen black, white, letting you know it's ready, and you take this receiver's NFC logo and the transmitter's NFC logo and you literally put them right next to each other. And they send the information across, and the transmitter will vibrate briefly in your hand because you can't see the displays as they're facing each other. But they're good to go now, and that is makes scanning and pairing exceptionally easy. But we did a very unique thing beyond that that also takes advantage of the NFC pairing. What we've done is, if you realize that the receivers also, besides the main audio output, we've got a headphone jack. So these guys can become personal monitoring devices on set. You can literally clip them to your belt, plug in a pair of headphones, use the plus and minus button to adjust volume as you need to, and now you may have a pile of these. You may be using them for camera hops, but you may also be using for all the people on set that want to be able to listen in. You could take a transmitter, hang it off of your mixer bag, hang it off of your cart, and you now have one frequency there that you've previously scanned and found was a great frequency, by the way, and you have a pile of receivers that all need to be set to listen to that transmitter. And all you do is you tell those receivers in their menu, go get your frequency information from a transmitter. You pick up the receiver, you hold it up to the transmitter, it vibrates, that one's done. Pick up another one, hold it up, it vibrates, that one's done. And you go through your entire pile of receivers, and they're all now listening to this same transmitter. Hand them out to everybody, and you've got very high quality sound, true double tuner diversity, frequency coordinatable with all of the actors, wireless that's out there, and these can even be, again, up in the 941 to 960 range. So that is a unique capability. Now, at Sony, we also obviously make cameras, and we also make wireless microphones. So our engineering groups got together and said, what could we do that would benefit both the camera world and the audio side of the world? And they came up with a technology called multi-interface shoe, or MI shoe for short. If you realize that a lot of cameras, or most every camera, has a little shoe mount on them, they're generally cold shoes, but we have been for years putting on this multi-interface shoe. It's a very intelligent hot shoe. And they exist starting all the way from our Alpha cameras and going all the way up into our FX9 these days. But what you can do is take this little multi-shoe adapter, attach it to the bottom of our receiver, and mount the whole affair right onto the camera. And audio will go right from the receiver down through the MI shoe directly into the camera without the need for external cables or anything like that. Click it on and away you go. As well, you don't even need to have batteries in the receiver, because you can also get your battery power sent from the camera's battery up through the shoe to power the receiver. Now, that's kind of cool. But we've taken that to the next level as well. In our latest generation of cameras, including the FX9, the A7R4, the A7S3, which just got introduced, the Z280, Z190, the Alpha A9 Mark II, they all have a digital MI shoe capability. We've always had analog MI shoe capabilities, but now we've got a little switch on this shoe that says analog or digital. If you use this on one of those cameras I just mentioned, you flip it to digital, and now you can pick the signal off of the receiver while it's inside the DSP and take the digital output, bypass the receiver's final D to A and the camera's additional A to D, and just go directly digital right into the video file of the camera, even improving things a bit there. So we've taken that into consideration. Now, another thing that we have done is on the transmitter, we've added a new capability, because in today's world, we're very green conscious, and there are green architects and green buildings. And what they have many times is occupancy sensors in a lot of the rooms. And those occupancy sensors, if they are of the ultra-high frequency type versus an infrared type that's commonly built into some wall switches, the ultra-high frequency models will emit either a 32 kilohertz tone or a 40 kilohertz tone, and then when people leave the room, it will turn the lights off and save energy. It's green. However, those very ultra-high frequencies can find their way into lavs, and they can have a little impact with the companding scheme and hurt your audio a little bit. So we have simply taken a little piece of the onboard DSP in the transmitter and said, you now be a digital filter that will filter out those upper frequencies. And you can set that to off and low and high, depending on the frequencies that you want to cut off. And that can get you out of a lot of trouble. That's a nice thing. One other feature I wanted to mention, and there are a lot more that we don't have time to go into, is a very clever capability of the receiver. You know how on your TV's remote control at home you've got a channel jump button or a last button, and you can flip back and forth between the last channel you're watching and the current one you're watching and go back and forth between your two favorite channels? Well, guess what? We have put that into this single channel receiver. So if you first pair up one transmitter and then you take another transmitter and you pair it up, you now have two frequencies that are in this receiver, in the channel memory. You go to the channel memory menu, and now by simply hitting the plus button or the minus button, either one repeatedly, it will alternate between those two frequencies. You can go back and forth between the two different transmitters. That may help out in certain situations. As well, on our transmitters, including our plug-on transmitter, which is also very much smaller in this latest generation, it has phantom power, by the way, to power up condenser microphones and shotguns or stick mics for news kind of thing. But both the body pack and the plug-on transmitter have mic and line level switching, so they will switch appropriately for those. Now finally, just to give you a sense, we also have a model called a UWP-D, and this guy is a true two-channel portable receiver and not very much bigger than the single channel model. You can tune in two completely independent channels, and what's also kind of nice is that at the bottom of each channel's menu there is a little built-in mixer control, so you can take that one receiver channel and send it out output 1 or output 2 or both output 1 and 2 simultaneously. And we also have a dedicated two-channel multi-interface shoe, and you can direct those out as well. And of course we give you cables to leave with the mini jacks and go out to a stereo mini or double minis to XLRs, and that all comes in the package. However, in addition to being able to take both channel 1 and channel 2 and either hard left, hard right, or monoize it down the middle, we have a completely unique feature and input on this receiver, which is a microphone input on the receiver. So at the camera position or at the bag position or wherever, you can put in another microphone. That can be a mono microphone, and it can even be a little stereo ambient microphone, for example, or another pair of inputs. And those can be mixed in with your two wireless channels, and they can be mapped hard left, hard right. They can be level matched and all that kind of stuff. You can get very creative with that, and that's kind of cool. So I think that is a pretty good overview of our UWP-D 4th generation family. Again, as I said, there's lots more capabilities in this stuff that we haven't really gone into. But if you would like more information on any of these products, simply go to sony.com/proaudio. And I do thank you for watching. Certainly go visit your favorite location sound dealer and ask for a demo of this UWP-D series. I think you'll be very impressed with it, and especially at the price point. So thanks for watching, and stay safe out there, everybody. Bye-bye.